This section deals with distance and midpoint formulas and circles. And out of that section, we're going to be looking at how to find the distance between 2 points, also finding the midpoint of a line segment, also writing the standard form of the circle's equation, and also give the center and radius of a circle whose equation is in standard form, and convert the general form of a circle's equation to standard form. We'll begin with the distance formula. If you're given two distinct points, x1, y1, and x2, y2, that distance, which we're going to call d, between those 2 points in the rectangular coordinate system is going to be d is equal to the square root of x2 minus x1 quantity square plus y2 minus y1 quantity square. You'll take the differences of your x coordinates and square it, and then you're going to take the differences of your y coordinates and square it, and then you'll take the sum of that and then take its square root, and that will give you the distance between those 2 points. All right, now let's look at this particular problem here. Let's say we want to find the distance between these 2 points, -4, 9, and 1, -3. Okay, so these are my 2 points, -4, 9, and 1, -3. And I want to find the distance between those 2 points. So here, the distance formula, of course, is the square root of x2 minus x1, and that's square, plus y2 minus y1, and that 2 is going to be squared. Now in this case here, my first point is -4, 9, so x1 will be -4, and y1 will be 9. And then for 1, -3, x2 is 1, y2 is -3. Okay, so here we're going to replace those variables in this distance formula with those values. So here, the distance is equal to the square root of x2 minus x1. Here's x2, that's x1. 1 minus -4. And that's squared. Plus y2 minus y1. Well, y2 is -3 and y1 is 9. So we're going to have -3 minus 9. And that's going to be squared. Now all we have to do here is just simplify what's underneath the radical. 1 minus a -4, and that's going to be 5. So here we're going to have 5 squared plus -3 minus 9 is -12, so that'll be -12. And that's going to be squared. And then we square the 5 and square the -12. In this case here, 5 squared is 25, plus -12, and you square it is -12 times -12. That's 144. And then add 144 to the 25, you'll get 169. So now you can have the square root of 169, and the square root of 169 is 13. So the distance between those 2 points, -4, 9, and 1, -3, would be 13. Okay, so that's how we find the distance between 2 points using the distance formula. Okay. The next thing we'll look at is the midpoint formula. This one's another easy formula to do because you're basically finding the ordered pairs of the midpoint. You'll be given 2 points, x1, y1, and x2, y2. So you're considering a line segment with those endpoints, x1, y1, and x2, y2. the coordinates of the segment's midpoint would be this. You'll take the sum of your x coordinates and divide that by 2. And then you'll take the sum of the y coordinates and divide that by 2. Those two numbers will give you the ordered pair or the coordinates of the midpoint of that line segment. All right, now let's look at an example that tells us how to find the midpoint. Here we want to find the midpoint of the line segment whose endpoints are 1, 2, and 7, negative 3. So we're looking at the ordered pairs 1, 2, and 7, negative 3. Okay, now we want to find the midpoint. Now, using that midpoint formula, we have x1 plus x2 divided by 2. And then the y coordinate of that midpoint is y1 plus y2 divided by 2. So in this case here, by looking at this, the first point is 1, 2, so x1 will be 1, y1 will be 2. And then for the second point, 7, negative 3, x2 will be 7, and y2 will be negative 3. Okay, so here we add the x coordinates together. That's 1 plus 7, and that's divided by 2. Y1 plus y2, that's 2 plus negative 3 over 2. Now 1 plus 7 is 8, so you're going to have 8 over 2. And then negative 2 plus 3, that's negative 1 over 2. Now, we can do 8 divided by 2. That's going to give us 4. But for negative 1/2, we'll just leave that as negative 1/2. So the midpoint of the line segment whose endpoints are 1, 2, and 7, negative 3 will be 4, 1/2. Okay, that ordered pair represents the midpoint of that line segment that contains those 2 points, or those 2 endpoints. Okay. All right, next we'll look at circles and how to graph circles. All right, a circle is the set of all points in a plane that are equidistant from a fixed point, which is called the center. Okay, so here this is an illustration of a circle, and that circle consists of the set of all the points that are in that plane, and they have the same distance from this fixed point that you see here, and that fixed point is called the center of the circle. So here, that fixed point there is the center, and the fixed distance from the circle's center to any point on that circle is called the radius. So this part right here, this line segment from the center of the circle to a point on the circle is called the radius. Okay. Okay, now these terms should be quite familiar, because if you've ever did the formula for finding the area of a circle, you have to know what the radius is. And of course, the circle does have a center in it. So those terms should be quite familiar. All right, now for the standard form of the equation of a circle with center called HK, and the radius R is going to be this formula: x minus h quantity square plus y minus k quantity square equals to r square. Okay, that's the formula for finding, well, that's the standard form of the equation of a circle. And here h and k are the center, r is the radius. Okay, now we're going to see how we can apply this particular formula to write the standard form of the equation of a circle. Take a look at this example here. Here we want to write the standard form of the equation of a circle with the center at 0, 0 and the radius at 4. So here, the center is at the origin, and the radius, I'm just going to say r, is going to be 4. Okay, now, and the formula, of course, or the standard form is x minus h quantity squared plus y minus k quantity squared equals r squared. Okay, now the center is 0, 0, so that means that h is 0 and k is 0. That's very important because the center is always hk. Now, we just replace the h and the k in this formula, and also r is 4, so we replace the r with 4. So here's what we're going to have. X minus h is 0, so that'll be x minus 0 squared plus y minus, and k is 0, so that's 0 squared, and that's equal to r, which is 4, so that's 4 squared. Now, x minus 0 is x, so that's going to be x squared, plus y minus 0 is y, so that'll be y squared, is equal to 4 squared is 4 times 4, which is 16. So, the equation in standard form for a circle with the center at the origin 0, 0, and the radius of 4 will be x squared plus y squared equal to 16. Okay. Okay, now let's say we had an equation. Well, let's say that the center was 0, 6, 0, negative 6, and the radius is 10. And we want to write the standard form of the equation of that circle. So here the center is not at the origin. It's at another point, 0, negative 6. And the radius is 10. Okay. Now again, the standard form is this: x minus h quantity squared plus y minus k quantity squared is equal to r squared. That's the standard form. So in this case here, 0, negative 6 is the center, so h is 0 and k is negative 6. And r is going to be 10. Okay, so here we have x minus h, which is 0. So that'll be x minus 0 squared. And then y minus k, which is negative 6, so it'll be y minus negative 6, and that's squared, is equal to r, which is 10, and that's squared. Now let's simplify this. X minus 0 is x, so that's x squared, plus, now y minus a negative 6 would just simply be y plus 6, and that's squared, equals 10 squared, that's 100. So this will be the standard form of the circle, or the equation of the circle, where the center is at 0, negative 6, and the radius is 10. X squared plus the quantity y plus 6 squared equals to 100. Okay. All right, the next thing we'll look at is how to use the standard form to graph the equation of a circle. So here we're given an equation that's in standard form. Now there are 3 parts to this. You want to find the center and the radius of the circle, whose equation is x plus 3 quantity squared plus y minus 1 quantity squared equals to 4. And then the B part is graphing the equation, and then the C part using the graph to identify the relations domain and range. So here's what we have. Now I'll go ahead and rewrite this on a blank sheet of paper. Here's x plus 3 quantity squared plus y minus 1 quantity squared. That's equal to 4. Okay, so here we see that this equation is in standard form, which is x minus h quantity squared plus y minus k quantity squared is equal to r squared. So here, the center is always h and k. Now with the h and the k, you always take the opposite sign, because the standard form is x minus h quantity squared and y minus k quantity squared. Look at x plus 3 quantity squared. For that to be a plus 3, that 3 had to be negative. So the x-coordinate of the vertex is negative 3. And this is already a minus, so we'll write that as a positive 1. So the center is negative 3, 1. And to find the radius, if r squared is 4, because that 4 represents r squared. Well, if r squared is 4, then r must be 2, because 2 to the second, or 2 squared, will give you 4. So you have to find out what number squared will give you that 4, and in this case is 2. So the radius here is 2. So finding the center and the radius of that circle was part A. Part B is graphing the equation. Okay, so here's what I'm going to do here. And I do have a coordinate grid here that I'll use here. Okay, so here, this is how we graph the equation of the circle. We first plot the center of the circle, which is negative 3, 1. So here we're going to go to the left 3 and up 1 and draw the point. That's the center of the circle. The radius is 2. In this case, the radius is always going to be the distance from the center of the circle to a point on the circle. So that means we go to the right, to the left, up, and down 2 places, because the radius is 2. Because that's where we're going to get our points that will be on the circle. Now, since that radius is 2, we start from the center and go to the right 2 and draw the point. And then from the center, we go to the left 2, draw the point. Again, from the center, we go up 2 and draw the point. And again, from the center, we go down 2 and draw the point. So to get those 4 points, you go to the right, to the left, up, and down, whatever the number of places is for your radius. So here, the radius is 2, so I had to go 2 to the right, 2 to the left, up 2, down 2. Now I use those 4 points to draw the circle. So here, this is the graph of that circle in standard form, x plus 3 quantity squared plus y minus 1 quantity squared equals to 4. And also part C, so here part B is the graph. Part C states that we need to use that graph to identify the relations functions, the relations domain and range. So here, if you look at this, those points to the left and to the right, and also up and down, can tell us the domain and the range. The domain, the farthest point to the left, now we're only looking at x values here, so the farthest x coordinate here is negative 5. All the way to the farthest x coordinate on the right hand side, that's negative 1. Okay, so this represents how far those x coordinates are. That represents your domain. The farthest y coordinates are the ones that go up and down. The lowest y coordinate was negative 1. The highest was 3. So the range here is from negative 1 to 3. And I'm using brackets because just so I can show you that those points are included. So the domain is the interval from -5 to 1 inclusive, and the range is from -1 to 3 also inclusive. Okay. All right, next we'll look at the general form of the equation of a circle. All right, this is the general form, which is, of course, x squared plus y squared plus dx plus ey plus f is equal to 0. In this case, d, e, and f are real numbers. Okay, so that's very important. That's what the general form of the equation of a circle is. And then on this next sheet, I have a little bit of review because we're going to be using that general form to write an equation in standard form. And the concept that we're going to have to use is completing the square. On one of the videos, we talked about completing the square when we were doing quadratic equations. So here, this is just a quick review. If x squared plus bx is a binomial, then when you add b over 2 and that quotient is squared, which is, of course, the square of half the coefficient of x, a perfect squared trinomial will result. Okay, so that means you'll have x squared plus bx, and then plus you'll take 1/2 the coefficient of x, which is, of course, b over 2, and then you'll square it. And then when you factor it, it's going to be x plus 1/2 the coefficient of x, and that quantity is going to be squared. Okay? Because we did some problems when we were solving quadratic equations by using the concept of completing the square. We're going to be using this again, this time to write equations of circles in standard form. So, let's look at one. Let's say we want to write this equation in standard form and do the graph. So here we got x squared plus y squared plus 4x minus 4y minus 1 equal to 0. I'm just rewriting this so that you can see how this is going to be done. X squared plus y squared plus 4x minus 4y minus 1 is equal to 0. Alright, the first thing I'm going to do here is group all the x's, and I'm going to group all the y's, and then I'm going to move the constant over to the opposite side. So, grouping all the x's, I'm going to have x squared plus 4x, and then I'm going to group the y's. I have y squared minus 4y, then equal to, now that minus 1, I'm going to move over to the opposite side, and that's going to give me just plain 1. So this is where I have x squared plus 4x plus y squared minus 4y equals to 1. Then the next step will be completing the square with the x squared plus 4x and the y squared plus 4y. Now, with the x squared plus 4x, when I complete the square, I take 1/2 of the coefficient of x. So 1/2 of 4 will be 2. And 2 squared will be 4. So this will be a plus 4 here. I'm going to write the rest of this down. Now keep in mind, if I add 4 to this side of the equation, I had to add 4 on the opposite side of that equation as well. So if you forgot about completing the square, I'm taking 1/2 of 4, that's going to be 2, and then square it, which will be 4. And similarly, with the y squared plus 4y, if I take 1/2 of negative 4, that's going to give me negative 2. And then negative 2 squared will be plus 4. So again, 1/2 of negative 4. I'll rewrite that again. 1/2 of negative 4. That's negative 2. then negative 2 squared will give me 4. So that I put a plus 4 here, but if I put that plus 4 here, I also got to do the same thing here on the opposite side. Add 4 to the other side. So keep in mind, whatever I do on one side, I have to do the same thing on the other side. Now, let's factor this and this. The x squared plus 4x plus 4 is a perfect square trinomial, which will be factored into. Now we know x squared, that's going to be x. The other term will be 1/2 of 4, which is 2. So that's plus 2. So I'll have x plus 2 quantity squared plus. Now if I take 1/2 of negative 4, that's going to give me minus 2. So this will be y minus 2 quantity squared. And then that's equal to add 1 plus 4 plus 4. That's 9. So this right here represents the equation in standard form. And from that, I can identify the center. Now these, you take the opposite sign. So here this was a plus 2, so that means it has to be a minus 2. And then this was a minus 2, that would be a positive 2. Because standard form is always x minus h quantity squared and y minus k quantity squared. So because it was a plus 2, the x coordinate of that center has to be a negative 2. And since it's already a minus 2, it would be a positive 2. And then the radius, if r squared is 9, that means that r must be equal to 3. You simply take the square root of that number right there to get your radius. So the radius is 3 and the center is going to be at negative 2 and 2. So let's go ahead and graph this particular circle. Okay, first we plot the center, which is negative 2, 2. So that means we go to the left 2 and up 2 and draw the point. The radius, I'll take this back so you can see, is 3. That means we go to the right 3 units, to the left 3 units, up 3 units, and down 3 units from the center of that circle. So here, from this center, I'm going to go to the right 1, 2, 3, draw the point. From the center, go up 1, 2, 3. From the center, go to the left 1, 2, 3. And from the center, we go down 1, 2, 3. So those 4 points are the points that will be on the circle. And here, we go ahead and connect those points and draw a circle. And that circle will be connecting those points. Okay? It's not the best looking circle, but it is a circle. And that represents the graph of the circle, in this case, of x squared plus 4x, well, x squared plus y squared plus 4x minus 4y minus 1 equal to 0, which is written in general form. Okay, so that's basically how you'll convert an equation that's in general form to standard form, and then use standard form to draw the graph of the circle. Okay, so that will conclude this particular section on distance, midpoint formulas, and circles.